Hi guys, welcome back from the ad break. So we are still looking at the deductive reasoning that we undergo in terms of geometry, right? Euclidean geometry in particular. So now we're going to be focusing on the triangles to try and now link triangles to this deductive reasoning. We say, how do I use deductive reasoning to talk about relationships between triangles? That's what we're going to try and do. So let's start by asking ourselves, what is a triangle? So, what is a triangle, right? As I said, a triangle, we know this is a closed 2D shape. Why 2D? Because this is a flat shape. That's what it simply means, right? 2D shape is a flat shape that is formed when three different line segments intersect at three different points. One line segment, let's call it A, B. Another line segment, let's call it B, C. Last line segment, let's call it A, C, right? And then what will we do? We will make all of these line segments to meet one another, right? To intersect and form this shape. So therefore it becomes, there's my A, there's my B there. Now I want the BC, so I'm starting at B, I'm going there, that is my C. I want my A and C, I'm starting at A, I go there, that is my AC. Voila, this becomes a triangle. And triangle, why? Because of the fact that we are talking about three sides, right? So as a result, this will have three sides and three angles as well, not necessarily equal to one another. It depends on what triangle you have. Now we have some classification on angles in terms of the types of the triangles that we have. We have what we call an acute angled triangle. This would mean the only angles you have in that are acute angles, right? The only angles you have are acute angles only, right, in that particular triangle. Then right-angled triangle, this one now does not necessarily mean, you see, my first description of what an acute angled triangle is, you don't really apply the same one here. It does not mean that there is three right-angled triangle, right angles in there. No, it just simply means that this has a 90-degree angle, right? 90-degree angle, right? Where one of the two segments meet, because remember they meet at 3 points. So one point of them must be at 90 degrees. And then with obtuse also we'll say at least one obtuse angle, at least one obtuse angle in that particular triangle angle. And then isosceles triangle, this then has some two properties that we need to look at. The first one is two equal sides, right? And we also have, because of that, two equal angles. And we actually start with equal angles because we're classifying it with angles, right? And then this will be the second point because of those angles being equal. Then the last one will be equilateral. Equilateral has three equal angles, and it also has three equal sides. See, so three equal angles and three equal sides. Now you can see my equal there looks very beautiful. Equal there, right? So three equal angles and three equal sides. Now let's see how we're going to try and apply all of these. You can see with this one here, let me just use a different color. This side is equals to that side, and that angle there will be equal to that angle there. So this will be considered the isosceles triangle that we have, right? And then let me just remove this. I'll just leave it as iso because then I won't have enough space. Then with this one, this angle, that angle, and that angle are all equal. As a result, this, that, and that will be equal. So this is therefore called the equilateral triangle, right? Now here you can see that I at least have one obtuse angle. This here is an obtuse angle in this particular triangle. So as a result, I will call this an obtused angle or an obtuse angled triangle. With this one, although it's not shown, I'm just showing you how we would see that it is a 90 degrees. It will be with that nice square of ours there, although mine looks like a rectangle. We normally show it as 90 degrees here. So as a result, this will be a right-angled triangle, right-angled triangle. And then the last one will be, this is different from that, which is different from that. This is different from that, which is also different from that. So as a result, none of the angles are equal. We can call it a scalene. Remember, this is a scalene triangle, right? So we have isosceles, we have equilateral, we have obtuse, we have right-angled triangle, and then a scalene triangle can also be called the acute angled triangle. Acute angled triangle, not angles. So it's acute angled triangle. Now, to try and apply this, some parts of a triangle, we have what we call a vertex, right? So these are the points where the lines meet, the sides meet with one another, right? So my C there will be a vertex, A there will be a vertex, B there will be a vertex. D is not a vertex because it is just a point. It is not where two lines meet. It can only be a vertex if two lines are meeting at that particular point. We also have sides, which are the line segments that I told you about. Now, we have what we call interior angles. So you see where I highlighted with yellow. I am not necessarily saying that all these three angles are equal. No, I'm just showing you where the interior angles are. And based on these interior angles, the exterior angle, right, which will be this one, there are conditions for it to take place. One side must be produced, right? Now I will give you the meaning of what produced is. Produced means extended. In order for us to talk about an exterior angle of a triangle or even of a quadrilateral, which we're going to talk about at a later stage. But for it to be considered an exterior angle, one side, let me show you. Here's my side here. This side AC. Side AC is extended up until D there so that it becomes one straight line. Therefore, this will be considered the exterior angle of this particular triangle. If I was to extend that one, my exterior angle will be there. If I was to extend that one, it will be there. If I was to extend, it will be there, and all of that. So please just know it can only have an exterior angle if one side is extended. Now we also have the right-angled triangle. Now this one is a very special type of a triangle, right? Where we can use things like Pythagoras, right? Theorem. We can also use the trigonometric ratios, although we are not talking about that now, right? The trig ratios. So we can use all of this, but for now, because we are still under geometry, we are only going to focus on the Pythagoras. Now, the Pythagoras theorem here will say the square of the hypotenuse side is equals to the sum of the other two squares, right, added together. So this is the hypotenuse side, which is my longer side, squared. This is equals to AB squared plus CA squared, or AC squared. Now, we have what you call equiangular. Now let's talk about this. Equi means equal, and then angular will mean angles, right? Equal angles. So if we're talking about equal angles, triangles, we're really talking about things that we can prove using similarity. And we need to just talk about the angles being equal, right? Because all corresponding angles must be equal. But you don't need to show all three of them. You can just show two angles to be equal. I promise you, the third one will be equal. So quickly, this is what I mean. If you say this is equals to that, and you say this is equals to that, automatically this will be equals to that there. So that's what I simply mean, right? You just need two. And as a result, corresponding sides will be in the same proportion. Then the last thing will be what we call congruency. Now with congruency, this has to do with identical triangles, where we then talking about equalness of this. But now with congruency, you don't need to prove all four theorems, right, or properties that I have. If you can prove one, I promise you, all the other ones are true, right? So if I can prove RHS, then all of this will be true. If I can prove SAS, which is side angle side, then all of the other things will be equal, right? So that's what we're trying to talk about there. So please make sure that you are clear on the properties of triangles and how we can use this. But when we come back, we're actually going to use all of what I've spoken about so far in trying to then prove some similarities, or just to even talk about relationships of angles. Please stay tuned. I'll be back just now.